Hello and welcome to this lecture of routing policy. Now routing policy, you can say is something that we implement on a router so that when a route is learnt by a router using different routing protocols, or when it is sending a route to other neighbors using different protocols, then we can kind of control the information that is being received or being fed. So let's assume that this is the router over here, this one, let's just carve it this way. And these are the neighbors that are sending information to this particular router. Now the routing policy is implemented before the information is received or is put into the routing table. And what we can do is that we can decline a certain number of routes to be entered into the routing table, or we can also modify certain parameters so that once these routes are installed into the routing table, they are installed or with different parameters, like maybe different preference, not preference value, like different metric values, or maybe different communities. If we are talking about BGP, different next hop, all these actions that can be taken in a routing policy. Not only that, routing policy implements the routing information that is entered into the routing table, but it also affects the information that is exported out of the routing table, like maybe to other neighbors, or even if it is exported to the forwarding table of the same very router. So this all is controlled and maintained by the administrators by employing different techniques through the routing policy implementations. Now there are some default routing policies for some of the protocols, like for BGP. If a router has got neighbor relationships established with different routers, and those routers have sent some BGP routes to this particular router, then by default all BGP routes will be accepted in the routing table. And likewise, if we have got peer relationship established with the other routers using BGP protocol, then all the routes learnt via BGP will be exported or re-advertised to the other neighbors. So it's like this. If I draw three routers over here and they are all running BGP and BGP and also BGP. So routes that are sent via this router A to router number B, and this one is C over here. The router B will accept all the routes into its main routing table that have been learnt via BGP protocol and will re-advertise them without any interference of administrator to router number C. In contrast to that, what OSPF does is that OSPF accepts all the routes and in its routing table and floods all the information to the other routers. Now why I'm saying that is because OSPF, you say, is a link state protocol, so it really does not share the routing information, rather it shares the, or sends the, or rather I should say that floods the link state advertisements and not the actual routes. So in case of OSPF, we really cannot control the OSPF protocol, OSPF information that is being learned in the route that is being fed to the other routers. Let's say if this router A over here, it is sending network 1, 2 and 3 networks are being sent to router number B, and we kind of implement a filter router number B that it should not put this network into its routing table. We can do that because routing table entries can be manipulated by routing policy. But once these three networks LSAs are received by router B, although that policy will be there to restrict the network number 2 to be entered into the routing table, but despite that, this router B will send all these three LSA's related information regarding these three networks to router number C. So if we have got no filter on router number C, router C will see all these three networks. So by default, OSPF accepts all routes, and by default it rejects everything. And since ISIS and OSPF are both link state protocols using the same algorithm, that is Dijkstra, to calculate the topology view and then calculate the shortest path to reach to the nodes, they both have the same characteristics as well as far as routing policies are concerned. Now RIP is a distance vector protocol, and the default policy for RIP is that it will accept all the routes from the neighbors that have been explicitly configured, and those routes will be entered into the main routing table, and by default it will reject everything. So if we have neighbor relationships with the routers, we need to explicitly export the routes to be sent to the other neighbors. So if we are to implement routing policies, it's just a pairing of from and then statement, and what we do is that we define a routing policy by any name that you want to use. For example, in this example it is using my policy, but you can name anything that you want to, and then in that very particular policy you define multiple terms, and in those multiple terms there are pairs of from and then statement. A from statement defines the criteria that should be matched, and a then statement is the action that is to be taken if that packet matches that criteria that is defined in the from statement. And also these statements are executed in sequential order. So if let's say we have got 10 terms in a certain policy and a packet matches term number 6 and an action is defined against that term, then the packet will not be matched against rest of the terms in that particular policy. Rather, the action will be taken, and based on that action, packet will be moved out of the policy actions. Now here are some of the criteria that we can define while we are to match the packets in a particular policy. We can use the prefix, or if I call it IP address. So let's say if we want to match IP 20.30.1.0 with a subnet mask of 16, so we can define this IP subnet as the prefix list, and this prefix can be considered in the from statement, that if a packet is coming from this particular subnet, or maybe even in from statement we can define that if a packet is going to this particular subnet. So in from statement, it's not necessary that if a packet is coming from certain network, it can be like source network, this one, network A, let's say, let's call this network A, or we can define in the very same from that a destination network is A, and if it is matches, then what action to take? Either let's say accept the packet or maybe drop the packet. Likewise, we can define the protocol. If the protocol is, let's say, maybe TCP or maybe UDP or maybe Telnet protocol like port number 23 or other such protocols that are supported in that particular implementation of Junos in a particular platform, because really these things kind of they really remain more or less the same in most of the platforms, but in some of the platforms they do tend to change, and not all the options are available in all the platforms. Likewise, one other criteria for selection of a packet is next hop, that where that packet is going to, and if it matches a certain next hop that we have defined in routing policy, then we can change the behavior, or we can take the action based on that particular matching, and we might drop the packet. Now there are also other matching criteria, a complete list that you can find out in Junos policy framework configuration guide. And besides that, there is also a concept of prefix lists and route filters. And what prefix list is that, just like I had mentioned over there earlier, is that we can define an IP address with a particular subnet mask. So let's say if I define that prefix list, let's call it prefix list number, or we can even name it like prefix list testing. And in that prefix list, we say that we have a network which is 1.2.3.4 with a subnet mask of 24. Now this prefix list, once defined, it can be used anywhere within the configuration of the Juniper router and many number of times or as many times as we want to. So we can refer to this prefix list in multiple maybe policy options, or maybe in routing protocols, or maybe in firewalls. So only one time this needs to be defined, and after that we can refer it by just its name and not typing the IP addresses each and every time. While on the other hand, these route filters, they are defined in particular routing policy and are only visible or significant in that very particular routing policy. So the route filters are also defined in this way, where we define a network and a subnet mask, but these route filters, they cannot be referenced in other portions of the Juniper router configuration. Now once we reference the prefix list or the route filters in a certain routing policy, then we do have some choices that we can make. Like if we have defined a network like this one over here, then prefix list supports these three options. That if we write this network, then we can say that exactly match this one, or we can say that match this network with this subnet mask or longer than this. And what does it mean is that if we have got network like 192.168.1.0/16 defined in the prefix list, and the criteria that we are defining in routing policy is that this network or longer than this, then this prefix list will match all the networks 192.168.2. let's say 1 or anything in these rightmost two octets. It will be matched using this criteria or longer. If we had defined exact, then it needs to be exactly matched these two octets. Likewise, what we can do is with an option of longer, then it would really mean that do not match this entry, but only those entries should be matched which are longer than this one. So if a routing update is received by the router which has a subnet mask of, let's say, 192.168, and we are not concerned about the other two octets, but the subnet mask that has been sent with the routing update is 17, then only these routes will be matched for that particular routing policy term. Now these upper three criteria, they are supported by the prefix list, but route filters not only support the upper three, but these lower two as well. So route filters, although they are kind of restricted as far as their presence in the configuration is concerned, but in routing policies they provide more granularity and flexibility as compared to prefix list. Like over here, we can also define a criteria with up to limit. Like if we are saying that we can filter routes using a particular prefix list that go from 16 and up to a subnet mask of 20, then we can do that by using the route filters. Or we can even define that particular range, like this over here, prefix length range. We can define that for IP addresses of 192.168 and starting from say 20 to 24, this is the subnet mask range. So we can define all these 5 types in the routing policies using the policy filters, but for prefix lists only upper 3 are supported. Now as far as actions and terminating actions, I should say, are concerned, if a packet is matched, then we can accept the packet or we can reject it as well. Or if we do not want a terminating action against a particular criteria, then we can also define that the packet should be, if it is matched against a certain term, then it should not be taken into a terminating action. Rather, it should be made to be compared with the next term or maybe even the next policy. So these are known as flow control actions. Another action type is that we can modify some of the attributes, like I had mentioned earlier, that we can change the next hop or the metric values or even the BGP communities that are used in the BGP routing protocol. So that's the brief overview of routing policy, and in the next lecture we will see that how to implement routing policy in the Juniper environment. So I hope you have learned from this video, and I would like to see you in the next one.